Hi there, good morning. Today is Thursday, April 23rd, 2020. We are going to be reviewing science today, okay? First, we are going to start talking about the states of matter. So please take out your student's book and open it on page 76. Okay, let's start. A liquid. A liquid has a definite volume, but not definite shape. The particles of a liquid can move by gliding past one another. A liquid takes the shape of its container. Forces hold a liquid's particles together, so a liquid keeps a definite volume. Solid. A solid has a definite shape and volume, or amount of space it takes up. The particles of a solid are very close together. For the most part, they stay in the same place. They don't slide easily past one another. Instead, they vibrate in place. Gas. A gas doesn't have a definite volume or shape. The particles of a gas are far apart compared to the particles of solids and liquids. A gas can be squeezed into a smaller volume. If a gas is placed in an empty container, its particles will spread out evenly. The gas will fill all the space and take the shape of that container. Okay, now we are going to talk about the chemical changes and the physical changes, okay? Look at the picture, please. Physical change of water into ice. Here, the particles didn't change, right? You can see it, the particles of the water are still the same. What changed was the state of matter. Now look, a chemical change of hydrogen peroxide into water. Look at the molecules. Look. And they changed, right? They were separated. Here you have two particles of, I do believe it's oxygen. Here you just have one, and these two are separated. Okay? It is important to understand the difference between chemical and physical changes. Some changes are obvious, but there are some basic ideas you should know. Physical changes are usually about physical states of matter. Chemical changes happen on a molecular level when you have two or more molecules that interact. Chemical changes happen when atomic bonds are broken or created during chemical reactions. These molecules were broken, okay, and they got separated. This is why this is a chemical change. No change to molecules. Water molecules always have the same structure. When you step on a can and crush it, you have forced a physical change. However, you only changed the shape of the can. It wasn't a change in the state of matter because the energy in the can did not change. Also, since this was a physical change, the molecules in the can are still the same molecules. No chemical bonds were created or broken. When you melt an ice cube, H2O, this is the molecule of the water, you have a physical change because you add energy. You added enough energy to create a phase change from solid to liquid. Physical actions such as changing temperature or pressure can cause physical changes. No chemical changes took place when you melted the ice. The water molecules are still water molecules. Changing the molecules. Look, these are molecules, iron molecules. Iron oxide, okay? These are the molecules. Iron atoms have a chemical change as pipes rust. Chemical changes happen on a much smaller scale. While some experiments show obvious chemical changes, such as a color change, most chemical changes are not visible. The chemical change as hydrogen peroxide H2O2 becomes water cannot be seen since both liquids are clear. However, behind the scenes, billions of chemical bonds are being created and destroyed. And when this happens, children, you can see bubbles. And that would be the only way that you could know that there was a chemical reaction. Okay? The only thing that you can see are bubbles. So here is a perfect chemical change example. Why? Because you can see it. Here, it is the iron. Okay? And here, it has rust, right? It's iron oxide, iron and oxide, the molecules. Okay? Now, I don't know why, but some of you got really confused about this topic. That's why we are going to review this, okay? The solution. Please look at this. It says, a solution is made by dissolving a solute in a solvent. The solute is added to the solvent. Okay, the particles are evenly mixed. And there's when you have a solution. Okay? A mixture in which substances are spread out evenly and will not settle is called a solution. Okay, in a solution, the substance that is dissolved is called the solute. It's solute, sorry children, it's solute. These particles, the blue particles, are the solute, okay? Then the substance, this yellow one, the substance in which the solute is being dissolved is called the solvent. Here, yellow one, and look at the word. It's in yellow color, okay? This is the solvent. I'm going to give you an example. Imagine a solution of sugar and water. The solute is sugar and the solvent is water. Water is sometimes called a universal solvent because it can dissolve many substances. Okay? What happens when a solid dissolves? Well, individual particles separate from the solid and spread evenly throughout the liquid. You can make solids dissolve in a liquid faster by stirring or heating the solution. It's better to dissolve like chocolate powder. It's better if you dissolve it in hot milk than in cold milk, right? Why? Because the temperature of the milk affects this solute, this solubility. So it's better when you have a hot or a warm solvent, okay? Now, we are going to watch a video. Okay, we are going to watch part of this video so that you have this topic very clear. Okay, ready? Let's start.
Solutions are mixtures of pure substances in which the pure substance particles are distributed throughout the entire volume of the mixture. The pure substance that is in the greatest abundance is referred to as the solvent. Water is the most common solvent. The other pure substance components of a solution are called solutes. Solvents, solutes, and solutions could be seen in all aspects of our lives. Let's look at some examples now. Water is the solvent, and salt is the solute. When we add them together, The solution would be salt water. The salt would be the solute because it is being dissolved in the solvent, water. Water is the solvent, and Kool-Aid powder is the solute. Together, the solution would be Kool-Aid. Not all solutions are liquids, they could also be solids. Here's an example of a solid solution that you might see in your chemistry class. Bronze is an alloy of 90% copper and 5% tin. Bronze is the solution. What is the solvent and solute? Pause the video now to think about the problem before moving forward. There is more copper, 95%, than tin at 5%. Therefore, copper would be the solvent and tin would be the solute. Now here's an example of a gas solution. Air is a solution of 78% nitrogen, 21% oxygen, and various other gases. Air is the solution. What is the solvent and the solute? There is more nitrogen than oxygen. Therefore, nitrogen would be the solvent and oxygen would be the solute. As you can see, solutions could be in all forms: gas, liquid, and solid. Now you know everything.
Okay, now to close this topic, many materials can dissolve in water and make a solution. You can dissolve more of some materials than others in the same amount of water. Some materials will not dissolve in water at all. This describes a material's solubility in water. Different substances can have different solubility in other solvents. Okay? Very good, children. I hope that you understood this topic. I hope that this was easy. And see you tomorrow. Okay? We are going to be reviewing social studies. Have an awesome day. Kiss for you. Bye-bye.